Hello, in this video we're going to look at doing some dosage calculations. Our first example is a word problem, and I actually think word problems are more challenging than ones that give us a label because we can get distracted by extra information. So we really need to think about what is it that we need in order to solve a dosing problem. And so it tells me the nurse is preparing to give this medication 60 milligrams as an IV. So the first thing I want to note is the 60 milligrams is what's ordered. Even though it did not say the word ordered, if that's what the nurse is preparing to give, the doctor must have told her, give this amount. Next, I notice the drug is available in a 2 milliliter ampule labeled 50 milligrams per milliliter. And I'm asked how many milliliters will the nurse administer. So in this medication vial, or ampule, there are 2 milliliters and there's 50 milligrams per milliliter. I only need one of those pieces of information. The one that I need is the second one, which is the strength. Knowing that there are 2 milliliters in the ampule is important, and I'll show you why at the end of the problem. But I don't actually want to use it as part of my math. So, as I've told you before, I'm going to stick with the dimensional analysis strategy, and I do that because it is the most robust strategy, and so it can solve any problem. The other strategies can work depending on the problem, but this one is universally going to work. In dimensional analysis, I always start with my order, so 60 milligrams. I make it a fraction, putting it over 1. Next, I need to cancel the label of milligrams. And so from the strength, which I have noted, I'll put the 50 milligrams in the denominator and the 1 ml on top. Canceling and then multiplying straight across, I get 60 over 50, and I divide that out to get an answer of 1.2 milliliters. So now, why would I need to know that there's a 2 milliliter ampule? Well, because I need to add 1.2 milliliters to this IV to administer this amount of med, knowing that it is a 2 milliliter ampule tells me there's enough medication in there. If it was a 1 milliliter ampule, I could pull out 1 milliliter from the first ampule, and then I would need a second ampule to get the additional amount. And so, helpful information, but as you can see, I did not use it in the calculation. I just used the strength, which is typically given on the label as a fraction and is given in this word problem as a fraction. Take a look at a second example. In this one, a dosage of 0.3 grams has been ordered. How much should you give the patient? So immediately 0.3 grams, this is my order. This label is challenging, which is why I put it in our notes, because when I go to look at the label, I don't have the fraction that I'm expecting. I see the name of the med, and it's a match to the order, and I see this 100 milligrams, and I see that there are 100 tablets. I see that they're chewable tablets. Sometimes with tablets, we find that the manufacturers don't write the word each on here. And so they just tell us 100 milligrams, and they are telling us that that is the amount per tablet. So with tablets and other pills, we can assume that this is per 1 tablet. So when I go to set up this problem, I always start with my order. So 0.3 grams, and having looked at the label, I see that the label was in milligrams. So my one strategy is to use King Henry. So King Henry died by drinking chocolate milk full of microorganisms. I have an order in grams, which is a base unit, and I would like it to be in milligrams. So that's 3 moves. So 1, 2, 3, so that creates 300 milligrams for the order. Then I can set up the 100 milligrams from the label in the denominator and I will put that over 1, assuming it is the 1, in this case tablet, and milligrams cancel. I do my math, and I see that I have to give them 3 tablets, which is a reasonable dose. In general, with swallowing pills, we think the numbers should be 3 or less. If you do a calculation for tablets or pills of any kind and it's more than 3, make sure to have someone double check your work. I also want to point out to you that I can do this problem all at once with the dimensional analysis strategy. So I can take the order of 0.3 grams, use the memorized fact that 1 gram is 1,000 milligrams, setting that up with the 1,000 on top to cancel the grams in the denominator, and then bringing in the strength of 100 milligrams in the denominator for 1 tablet. And this will also give me the exact same answer without using the King-Henry mnemonic device. We're going to look at one additional example here, and this one is an order for us to add 20 milliequivalents of potassium chloride to an IV bag. So the 20 milliequivalents is serving as my order, even though the word wasn't there. And it's available based on the label above. So I'm going to set up my dimensional analysis strategy. I'll be starting with my order, 20 milliequivalents over 1. When I look at the label, the thing that immediately catches my eye is this 40 milliequivalents in the black box. However, that does not have a volume with it. And so since it does not give me a conversion, it's not the piece of information that I need. If I go directly above that black box, I see the fraction that I actually need, which is telling me that there are 2 milliequivalents per milliliter. So setting up with the fraction, 2 milliequivalents go on the bottom, 1 milliliter on top, milliequivalents cancels. I do the math, multiplying straight across and get 10 milliliters. Now, just to point out to you that you could have made the problem work using that 40 milliequivalents that caught our eye. So if I start with the order of 20 milliequivalents over 1, and the 40 milliequivalents catches my eye, I put it in the denominator. The 40 milliequivalents is the total amount in the container. And I see that right beside the 40 milliequivalents is that it is a 20 milliliter single dose vial. So I can use the 20 milliliters with the 40, and my numbers are bigger, but the math turns out to be the same, that you would administer 10 milliliters by adding it to the IV bag. So it works either way. In general, though, we want to be looking for a fraction. But as we've seen in this video, pills sometimes don't give us the fraction. And as we see in this label, the reduced fraction or the fraction made with the total amounts in the container end up giving us the exact same answer.